Hello everyone, and welcome to your video on rationalizing the denominator. Now, you might first want to know even what does that mean to rationalize a denominator. And what that means is that we are going to get rid of any radical signs that are in the denominator. We cannot get rid of all radical signs, but we do not like radical signs in the bottoms of our fractions. That is very bad form. So we're going to get rid of that. So before we go too much further, we're going to do a little short tutorial over here that I think will help you understand why this technique is going to work. So, for instance, what do we get if we multiply radical 5 times radical 5? We get 5. What do we get if we multiply radical 2 times radical 2? We get 2. What do we get if we multiply radical 8 times radical 8? We get 8. Do you see the pattern here? Even if I make it harder, even if I make it like, what if I multiply the square root of 3x to the 7th times the square root of 3x to the 7th? What do I get? I get 3x to the 7th outside of my radical sign. So basically, if I multiply a square root times itself, that has the effect of making the square root disappear. Oh, sweet! So, do you see where we're going with this? I'm going to multiply this fraction by this particular version of the number 1. Remember, 1 is what you get whenever you have any number divided by itself. 3 divided by 3 is 1. 407 divided by 407 is 1. 2x squared divided by 2x squared is 1. In this case, root 5 over root 5 is 1. So I'm multiplying this fraction by the number 1, which won't change the value of the fraction, but it will be able to help me change the way it looks. So in the bottom of this fraction, I have radical 5 times radical 5, which gives me 5, just like over here. And on top, I have 2 times radical 5, which is just written like that, 2 with a radical 5 right next to it. This is the rationalized version of this. This is better than this. Or I shouldn't say, it's not better, it's in better form than that. Whenever you get an answer that has a radical sign in the denominator, you must rationalize that denominator and get rid of that radical sign. So, 2 root 5 over 5. Let's try another one. Let's try 3x over root 7. And we want to rationalize that denominator. So we're going to multiply this by root 7 over root 7. And what will we get? Well, we're going to get on the bottom, root 7 times root 7 is just plain old 7. That's just like what we practiced over here. And up here on top, I'm going to get 3x root 7. 3x times root 7. There you go. We are now done rationalizing that denominator. That's pretty easy, right? Okay, it doesn't get too much harder than that. We could do one like this, where I do 9 root 6 over root 4. No, let's not do 4. Let's do root 5. Okay. All right, so 9 root 6 over root 5. We're going to rationalize the denominator. So we're going to multiply by root 5 over root 5. And that will give us 9 root 6 root 5 over plain old 5. Now, obviously, this is not in good form because we know that we can just multiply those together into something beautiful. So let's do that. So this will be 9 root 30 over 5. Now the question is can we reduce that root 30 at all? And I'm pretty sure that the answer to that question is no. So that's going to be my final answer. But I think that we should talk about how I knew it was no. So here's our problem. 9 root 30 over 5. We want to know if we can break down that root 30. In order to know that, we need to know our perfect squares. And when I say know them, I mean know them. Like in the same way that you know that it goes A, B, C, D, and that 2 plus 2 is 4, and that you can never divide by 0. In the same way, you need to know what your perfect squares are. So 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. That's enough for today. These right here on this side are called perfect squares. Because you can find a number that you can multiply by itself, a normal number, like 5 times 5 is 25, 6 times 6 is 36. Well, you need to know these because you need to know if any of these numbers can go into this number. And in this case, in 30, you can't, because you can only make 30 a couple of different ways. You can do 10 times 3. You could do 30 times 1, and you could do 6 times 5. And none of these appear in this column. So you can't reduce it at all. All right, let's do one more that might have to be reduced. Let's do 4 radical 5 over radical 5. Okay, let's do that. So there's a couple of things that you might do. You might do multiplying the numerator and the denominator by radical 5, and that would give you 4 radical 5 times radical 5 over radical 5 times radical 5 is just plain old 5. And then you would combine these into 4 radical 25 over 5. And then you would know that 25 is a perfect square of 5, so you would change it into 4 times 5 over 5, which is 20 over 5, which is 4. Okay, so you could do that. However, if you've had enough Diet Coke and you're completely awake with a good night of sleep, you could say to yourself, here's my fraction. I have no plus and minus signs to mess me up, so I can just cancel those out, and 4 is what remains. So again, just like in the last chapter, you can take the long circuitous route to get to your answer, or you could take the short direct route to get to your answer. It really doesn't matter, except that this one is less frustrating. This one can be kind of fun, but this one's less frustrating. Okay, there's one more thing that I want to show you about rationalizing the denominator. So far, we have learned that if you have a fraction with a square root in the bottom, that you multiply it by itself, and that has the effect of erasing that radical sign in the denominator. It gets a little more challenging when we have a fraction that looks like this. This is more challenging because it's not the entire denominator that is underneath the radical sign. It's just part of it. And we cannot just multiply the top and bottom times radical 3 because when we FOIL this with anything, we would still wind up with a radical sign. So we need to multiply it by something called the conjugate. The conjugate? What in the world is the conjugate? Well, it's a fancy name that means the same equation, but change the sign. The same equation, but change the sign. So here it was a negative sign, so we're going to change it into a positive sign. The result of this is actually pretty beautiful. I'm going to do it for you up here. So if we have x minus radical 3 times x plus radical 3, let's see what we can do. I'm going to change this into plus a negative radical 3. X times x is x squared. X times the square root of 3 equals x root 3. Negative square root of 3 times x gives me negative x root 3. And negative root 3 times positive root 3 gives me a negative 3. These two terms cancel out. So I'm left with x squared minus 3. So here I have x squared minus 3, and on top I have 3 times x plus radical 3. So again, this is the preferred form. We don't like this because we don't like radical signs in the denominator. So when you have two terms like this, you multiply the numerator and the denominator by the conjugate of that term. Let's do just one more. Let's do this one. Let's do 4x over the square root of m plus 2. 4x over the square root of m plus 2. So again, we have these two terms here in the denominator. And so we are going to multiply them by the conjugate, which is the square root of m minus 2. The square root of m minus 2. So then, what do we get? Well, I'll tell you what we get. We get, this is going to be m, the square root of m times the square root of m is going to give you m, and 2 times negative 2 is going to give you negative 4. That's what you're going to get here on the bottom. 4x times root m minus 2 on the top. Now, even though I did that without actually writing out the FOIL method, does not mean that you should unless you are sure that you know what you're doing. The square root of m plus 2 times the square root of m minus 2. Let's FOIL it out, okay? Square root of m times the square root of m gives you m. Square root of m times negative 2 gives you negative 2 root m. 2 times root m gives you 2 root m. And 2 times negative 2 gives you negative 4. These two terms, this one is negative and this one is positive, so they cancel out, leaving you with m minus 4. That is how I got there. It's just, I know that if you multiply by the conjugate, you get the square of this minus the square of that. All right, that is how you handle rationalizing the denominator, and it does not get much harder than that. So, good luck to you.